Hi everyone, myself Benny John, Assistant Professor. Today we are going to see about theory of machines, that is force analysis. In this you see about dynamic analysis. That's the first one. Dynamic analysis is based on graphical or analytical methods using where to find about velocity and acceleration of the reciprocating parts. The velocity and acceleration by graphical method we can determine that Kellin's construction, Ritter's construction, and Bennett's construction. Next, while dynamic analysis, this is shown in the figure, that is analytical method, consider the motion of crank and connecting rod, the reciprocating system shown in figure. That's the circular motion towards the crank is rotates and the piston move up and down motion. That's shown as the length measures, and P dash to P, that's shown as letters X, and P dash to C dash, that is a L. Next one is the dynamic analysis. Next one is considered the continuous. The OC is the crank and PC is the connecting rod. Less the crank rotates with angular velocity, the radian per second, and crank returns through the angle theta from the inner depth sensor. Let us consider the SB, XB, the displacement and reciprocity of the body from the IDC after the time per second. Let us L equal to length of connecting rod, R be the radius of crank, theta be the inclination of crank, N be the ratio of length of connecting rod, that is N equal to L by R. So from the figure we can find that cos pi equal to 1 minus sin square pi by the whole square of half. That's otherwise known as 1 minus sin square theta by n square the whole square of 1 by 2. The expanding the expression with the binomial theorem, we can get 1 minus sin pi equal to sin square theta by 2n square. This is graphically written. That's a figure showed x equal to r into 1 minus cos theta plus sin square theta by 2n. That we can differentiate with velocity O, as we can get velocity maximum VPO equal to omega r into sin theta plus sin 2 theta by 2n. And there is the acceleration. We can find that the formula, there will be ap equal to omega square dot r into cos theta plus cos 2 theta by n. When the crank rotates, the inner ratio as per the radius of, therefore signing expression ap equal to omega square plus r into 1 minus 1 by n. Next one is the piston of reciprocating engine, that is piston effect. This is a net force acting on the piston or crosshead pin along with line. It is denoted by F. Next is the formula is known as F equal to net load plus or minus inertia. That is the formula is FL plus or minus F1. This is RF is inserted considered as, that is a frictional resistance. While the negative sign used when the piston is accelerated and positive sign will be piston is retarded. In double acting cylinder, the piston effect shows that P1 A1 minus P2 into A1 minus A. The P1 and A1 represent pressure and cross-sectional area of back end, and P2 and A2 will the pressure and cross-sectional area of crank end side, while the A is cross-sectional area of piston rod. And when the piston rod is act on piston effect, there's a formula of FL equal to P by P into pi by 4 into D square. Next one, the force acting on connecting rod. The force is given as Fp equal to cos pi. So Similarly, applying the cos by the square root of 1 minus sine square theta by n square, the fq equal to fp by square root of 1 minus sine square theta by n square. Next formula is thrust. To find the thrust, the Fn is denoted as thrust equal to Fq sin pi. That's also substituting Fp by cos pi into sin pi. Similarly, the thrust equal to Fp tan pi. Next one is crank pin effort. Ft equal to Fq sin into theta plus pi equal to Fp by cos pi into sin theta plus pi. Next, thrust on crankshaft bearing. Thus Fp equal to the Fp by cos pi into cos theta plus pi. Next, crank effect or turning moment. It is useful to turning moment means it is known as the product of crank pin effort and crank pin radius is known as turning moment effect. That T equal to F into. That's all. Thank you.